I want to tell you the story of a fintech company that almost lost a major deal because they handled chunking badly. You might think, what is chunking? Chunking is the foundation of so much efficient context engineering and data work with AI. It sounds boring. I know it sounds boring, but we are going to go through it together. I'm going to lay out the key principles of chunking and embedding, and I'm going to explain why they matter. This is the number one question I get as soon as people understand that they need to put their data into a position where they make it ready for the AI. They're like, okay, so I need something. Oh, it's probably a RAG, a retrieval augmented generation system. Well, now what? And this is where chunking appears. Now what is chunking? And if you can't cut your text into the appropriate sized chunks, you're going to get into huge trouble. And we're going to get into a lot of specifics on this. Buckle in, get excited, grab some coffee. Okay, so this fintech company, their AI chatbot was asked about indemnification for an NDA. The contract said party A indemnifies party B in one chunk and except as provided in section whatever in the next chunk. It broke in the middle of the sentence because they were using every so many token chunking. So the AI retrieved only the first chunk and confidently said party A fully indemnifies party B. That's the wrong answer, and it took a lot of billable hours to clean up. Here's the thing. That was not a model intelligence problem. I've seen that happen over and over again. You get an inaccurate response, and people assume this will get fixed when ChatGPT 5 comes out. It won't, because it's a problem of context engineering. You're not chunking your data right, and it matters. I've consulted with a lot of companies implementing RAG, and this is the top question. It's not which embedding model, it's how should we chunk our data? That's what matters. It's not how do we prevent hallucinations? That is actually also a question of chunking. People just don't know how to ask it. So if chunking is the foundation that everything builds on, how do you think about it in the context of your overall pipeline? First, let's understand how RAG and let's understand how retrieval augmented generation and how AI works together with chunking to get you answers very briefly. So when someone asks a question of AI, you are going to get 3 to 5 chunks back, and that is what the system is going to depend on to formulate an answer. And those chunks are going to be retrieved by their semantic fit to the query. And so if the true answer got split across multiple chunks and part of it is missing from that 3 to 5 chunk set, like I described, you're not going to get the right answer. It doesn't matter how smart the model is. Chunking also directly impacts your costs. Bad chunking means retrieving more chunks than you need to get the information you need. Pulling more chunks means pulling more tokens, loading more into the context window, which could overwhelm the system and ironically produce less accurate responses because it has so much meaningless context in there. Companies can reduce their bills to major model makers significantly, like double-digit percentages, by getting chunking right. And again, I'm just going to say this one more time. Chunking is one of your first lines of defense against models hallucinating. You think models hallucinate because the model itself is bad. What you don't realize is that what else is the model going to do when you give it bad chunks with incomplete information? The AI fills in the gaps. That's where the hallucinations come from, and that's really on you for not chunking well. Now, some of you are going to raise your hands at this point, and you're going to say, Nate, I've heard about this thing called Agentic Search. It uses AI agents, so it must be cool. Why would we chunk at all? Well, that's a fair question. Agentic Search is a different technology. An AI agent can iteratively search and then read and then reason and then search again. And it seems like it could sidestep chunking all the way. Certain use cases, that's true. If you have a complex use case, you're reasoning across multiple types of data at the same time, Agentic Search can be really, really effective. It's great for exploratory queries. It's great for answering complex challenges like, what is the total impact of our Q3 marketing campaign across all channels, right? Like that kind of a query where you're going to have to go and look at multiple tables, you're going to have to reason, you're going to have to sum, et cetera, do some math, come back with an answer. There's a lot in that one sentence. RAG is more foundational and chunking is more foundational. RAG is good at solving the problem of fast economic retrieval, and chunking is how you get that retrieval to be accurate. Chunking it's like eating your vegetables. People don't think of it as a super amazing technology that's sexy, but that doesn't matter. You either have accurate retrieval and low hallucinations at an economical price, or you pay a lot For agentic search, that's going to be a lot slower. And those are both step change differences. Agentic search can be 10 or more times slower than a good RAG retrieval, and it can be 10 or more times more expensive. Do you really want to 10x your expenses just to use agentic search and sidestep the hard conversations around embeddings and chunking? Most businesses don't when they actually sit down and pencil out the math. So this is where RAG wins. RAG wins when you need consistent responses, and you need them fast, and they need to be economical. And the questions relatively cleanly map to specific information. You can retrieve the answers. When the cost per query matters at scale, when you need predictable behavior, when queries are often semantic meaning related lookups. Those are all cases where good chunking strategy wins. And we will go through some use cases. There's a lot of them that you can dig into. On the other hand, I recommend agentic search to some companies. It matters, and it makes a difference when you're using multi-step reasoning with a query. It matters when information is scattered across a whole lot of documents, so retrieving the chunks would be very difficult. It matters when you need to follow references, you need to follow links. It matters when the path to the answer is really unknown. Agentic search can be really helpful. So the point is, agentic searching is helpful, is useful. But interestingly enough, if you've been watching this far, you'll realize that agentic systems also rely on good chunking because they are also involved in picking out semantic information. What I said, information scattered across many documents, that gets easier with chunking. Following references and links, it would sure help if the references and links were in the same semantic unit of meaning as the original context. Multi-step reasoning is easier when you have clearly labeled chunks that actually work as individual units of content. All of this stuff, this boring chunking stuff, turns out to add value not just to cheap, efficient RAG, but also to agentic search. So let's get into chunking a little bit, and we'll talk about the 5 principles of effective chunking. When you build a retrieval augmented generation system, you're not just feeding the whole document into AI and saying, God bless, right? Off you go. You have to break it into pieces, into chunks that get stored in a vector database. So your AI is taking an open book exam, right? And someone has to tear that book page by page into little chunks. And if you tear it wrong, your AI is reading half the sentence. That's what you need to have in your head as a picture. You're giving the AI a book, but you're giving it in pieces, and you have to have it retrieve the right piece to get the answer. So bad chunking is responsible for a huge amount of RAG failures and realistic production pipelines. And it can take weeks or months. I've had teams spend months working on figuring out chunking strategies so that they get all of the meaning in the query. And they end up iterating and iterating and iterating to get there. I would like to make that easy for you. I would like to make you more of an expert on chunking than I was when I got started. So let me lay out the 5 principles of effective chunking that I've seen work over and over again. Number 1, context coherence. You are doing context engineering when you chunk. Never split meaning. Your AI can only work with what's in the chunk that it retrieves. If you split the defendant shall pay damages into one chunk and unless gross negligence is proven into another chunk, you've created a hallucination waiting to happen. Respect natural boundaries. For contracts, that would be sections and subsections. If it's code, it might be functions and classes. I'm going to talk a little bit more about code. Code is an interesting case. For conversations, it's usually speaker turns. It might be time windows. Every data type has semantic boundaries. Take the time to find them and use them. Principle number 2, there are 3 levers that you can control in chunking and know how to use them. Boundaries, size, and overlap. Boundaries are where you cut. Maybe by sentence, by paragraph, by section, whatever makes semantic sense. Size is how big each chunk gets. It's not an arbitrary token count. It should be a complete unit of meaning. And overlap is an insurance policy. It is often the case that you are 10, 15, 20% overlapped on your chunks because you don't want to have breaks in your chunks that give you the risks I've described with AI hallucinating contracts. Most people only think about size. They'll set it at whatever 1,000 tokens and call it good. You don't want to live in that world because then you're just ripping the pages off and it doesn't matter in this book that we're imagining AI reading. And AI is going to be really confused reading the book because it's ripped in weird places. It's not ripped at the chapter breaks or the section breaks. Okay. So know your levers, no boundaries, no size, no overlap. Use them all and use them in a way that respects principle number 1, context coherence. Third principle, data type is going to dictate your strategy. This is where we'll get back into the code piece a little bit. A legal contract chunks differently than source code, which everyone would envision as true, but so few people think about it that way. You can split on section markers in a legal contract, and that's typically labeled really cleanly. You want to be in a place where you include the full hierarchy of contracts in metadata so that it's easy to read and understand. Financial tables. This can get complex. Tables tend to have orthogonal relationships. Rows relate to columns, cells reference other cells, formulas depend on ranges. A simple row-by-row chunk does not work, so I'm going to get in a second and explain to you an approach that can help a bit with financial tables. And then we'll get into sort of where to use that versus maybe where to use agentic search. And then let's talk about source code too. To me, that is the biggest elephant in the room. Do you use real code and look at all the dependencies and try and build a semantically meaningful RAG system with good chunking? How do you do it? So in reality, if you have really clean code, which most people don't, and your functions are pure and self-contained, it is possible to have very useful semantic chunking with source code that enables you to retrieve bits of code and actually operate against them. Oftentimes, you need to be in a place where you are retrieving information across a really messy dependency tree. So your function might call 3 other functions. It references class variables that are not local, uses imported modules, whatever it may be. Your code has side effects. Everybody's does. So the best way to think about it is if you were going to find use and value out of chunking code, take the time to build dependency graphs. Take the time to include all called functions in your metadata. Consider something like neighborhood chunking, where you include the function plus everything that it's going to call in one chunk. And if the code is really highly coupled together, you might need to chunk like an entire class or an entire module of code together. The best strategy, if you really want clean, semantically meaningful code, is sometimes to refactor it. And by the way, AI is good at that. That's a separate conversation, but AI can be quite good at that. Bad code architecture leads to a huge amount of difficulty with chunks. And that, by the way, that is why a lot of organizations that are trying to figure out how to get their code into AI are employing agentic search. Agentic search enables them to not have to immediately refactor their bad code. And instead, they're going to burn tokens and have an agentic search reason across a large and messy code base. Is it perfect? No. Is it expensive? Yes. Is it something that may be a way for them to go forward because they know that chunking is going to be hard here? Also, yes. Now let's dive a little bit more into Excel. I think this deserves its own section because I see a lot of disasters here. Excel data isn't just rows and columns. You're basically preserving a web of relationships. So the marketing dashboard might have a time series that runs horizontally and categories that run vertically and formulas that reference various ranges, etc. You can't chunk it row by row and expect it to work. So here's a few ways that people approach this. One, again, you can go back to agentic search. Sometimes that happens. Or if you really want to get useful semantic meaning, think about the natural semantic chunks. And so you could take a particular time window and chunk that and include all categories like Q3 2024, chunk that. For formula heavy sheets, you may want to trace dependencies, build a map, and chunk calculable units together. Like if cells A1 to A10 feed to a summary in B15, they would all be the same chunk. This also takes work. Again, the AI is norming us and pushing us toward cleaner code and cleaner spreadsheets here. And that is absolutely going to be a trend in the workplace. If you're using pivot tables, if you're using summaries, you want to duplicate the summary in each chunk or create a very clear hierarchy so that detailed chunks can reference a summary chunk. You want to be, again, clear about what each thing does. And sometimes it is possible, if you really want the semantic meaning, that you will need to extract and convert the pivot table or whatever the Excel sheet is into natural language. I don't see that happen very often. If it gets that bad, most people go back to agentic search because at least it works with the messy data a little bit. Even so, if you are dealing with a situation where you have a lot of complex financial data, I would recommend that you look at the semantic borders and meaning of your financial data, because as we discussed at the top, agentic search isn't a silver bullet. It still needs good chunking strategies, if you have them, to retrieve stuff effectively. In a sense, one of the things I want you to take away here is there's no such thing as a free lunch. There is no way to easily and intuitively get away with not chunking well, and agentic search is not a get out of jail free card on that one. You have to wrestle with the challenge of your own messy data. And AI forces you to confront it if you want the benefits of reasoning with machine intelligence across your data sets. Let's go to the fourth principle. You want to size for Goldilocks outcomes. If your chunks are too small and your chunks lack context, your AI at best will say, I don't know a lot. If they're too big, you're wasting a lot of tokens, your answers will be really unfocused, and you're paying more. So you want to think about the sweet spot that reflects both the semantic meaning in the data and the natural language answer you want. And so maybe for legal clauses, that ends up being 750 tokens, somewhere between 500 and 1,000, something like that. Maybe for technical documents, it's longer. They're more complex. I know the irony, right? Technical docs could be more complex than legal docs. So maybe it's closer to 1,000 all the time. For coupled code, you can have like really large chunks where like entire classes or modules are in there. They can get into the thousands of tokens. Time series data, if you're pulling a full period with all context, again, that can be a somewhat sizable piece of context. It could run over 1,000 tokens. And the key is not, Nate said it was going to be X token, so that's what we use. I've been saying the entire video, don't use an arbitrary token boundary. Go for semantic meaning. You want to build an evaluation set, and you want to test these evaluation questions against various chunking strategies until you find one that works. Evals win. Accuracy is going to max if you try different chunking strategies against a common evaluation set of questions. All right, fifth and final principle, remember overlap. Remember overlap. Gets underused so much. Overlap means the end of chunk A appears at the beginning of chunk B. And this matters because important information can still span boundaries sometimes. No matter how good your semantic splits are, they may not be perfect. And if you have a big enough data set, you may not be able to hand check every split. And so you have to have some overlap as insurance. One of the catches is if you have orthogonal data like spreadsheets, which way do you overlap? For time series, maybe it's a temporal overlap where you include like a summary from the previous period. For categorical data, is it a category overlap? It's one of the things that like gets sort of fraught when you get into the details. And this is why I'm making this video, is I want to surface and sunlight these conversations so that everyone knows that we're all having this discussion. It's a big question and it's easier to have it as an AI community so that we can actually review it effectively. I have looked at documentation, blogs, how you get started on chunking from a lot of different sources. And for the most part, it's people shilling their own solutions. I don't have a solution to shill. I'm just trying to build best practices into the community here so that we have an easier job building in effective data sets that we can retrieve against and reason against with machine learning, with AI. So your leverage point in building any kind of retrieval augmented generation system in context engineering is getting the context right. And that comes down to chunking strategies and embedding, which is why we're just drilling on this so hard. So if that's you, if you've been struggling with chunking, if you don't know where to get started, I want you to run a little bit of an audit on your current strategy. Are you using flat token and character splits? Are you having no overlap between your chunks? Are you using the same strategy for all your data types? Are you not preserving metadata? Are you splitting in ways that ignore document structure? These are all common issues. Is financial data chunked with no thought for relationship preservation? The fixes aren't simple. You are wrestling with the structure of the data itself and how it expresses semantic meaning. I am not here to pretend it's an easy solve, but it is the way forward toward truly transformative AI retrieval. It is the difference between, well, the AI kind of makes sense when it looks at our big pile of messy data, or, wow, that is on point, that is correct, we use it all the time. If you want that latter world, you cannot treat chunking as an afterthought. It's the foundation for AI performance if you have a large data set. Bad chunking poisons everything downstream, whether that's RAG performance or prompt engineering or model upgrades or even agentic search. You need to start with your highest value and most problematic data type and just run into that pain, run into the spaghetti nature of that data and map it out and figure out how you're going to deal with the chunking side and fix it. Apply those 5 principles and fix it. Sometimes what you are really wrestling with is the fact that you made data architecture decisions that are very difficult to undo. And so it's possible that you will need to re-architect your data sets for AI. And I see companies being willing to do it because they see the benefits of AI. They were not willing to do it for the cloud, right? They were not willing to do it for a SaaS company and their SaaS tool. They will do it for AI. And they will do it for AI because they see the benefits. Getting data architecture right matters. If you are in the data architecture space as a specialist, someone who designs good data architectures, you have a sweet job right now. People need your expertise. If you really want to get your data into AI in a way that generates that step change in value that everybody on LinkedIn likes to brag about. Not everybody on LinkedIn is actually telling the truth, but we all know that. The value is actually there. It's just there when you put the hard work in. And this, by the way, this whole conversation, the fact that I have to make this video is why it is so difficult to just stamp out solutions for companies. Companies all have different flavors of painful data, all have different messes. Every data set is painful in its own way. And so you need to be able to take these principles and figure out in your data environment what chunking strategies make sense. And that's why I've leaned on principles so much, because I think that in the end, that is the only thing that really scales across really complex corporate data sets. I looked at a bunch, and these are the things that keep standing out. You got to maintain context coherence. You have to be aware of boundaries, size, and overlap, your 3 levers. Number 3, you should recognize that data type is dictating your strategy. We talked about Excel. We talked about code. We talked a little bit about legal. You think about the data type. We talked about conversations a little bit. And then make sure that you are actually getting your size right. So size for Goldilocks outcomes. That's principle number 4. Don't size them too big, or you're going to get vague answers. Don't size them too small, or you're going to get unfocused, hallucinated answers. And then the 5th principle, remember overlap. Remember overlap. Remember overlap. There you go. Those are the principles. That is why embeddings matter. I don't want you to walk away from this and think that there is a handy silver bullet alternative. Chunking matters, and we don't talk about it enough. Cheers.